What comes after the International Space Station? The first results from Euclid. There's hope for the TRAPPIST-1 planets after all, and a triple star system with a black hole. All this and more in this week's Space Bites. We've talked quite a lot about how NASA is planning to deorbit the International Space Station by 2030. And this does not set well with you in the comments, and you are proposing all kinds of ideas about where we could send the International Space Station, or we could recycle it or something. It's probably going to be deorbited and burn up before 2030 and be deposited in the ocean. Like we all just need to come to grips emotionally with this reality. But there will still be other space stations orbiting around the Earth. Of course, there will be the Chinese space station, but NASA astronauts won't be able to visit that. But there are plans to build a private space station from a company called VAST, and their station concept is called Haven. They've actually designed two versions of Haven. So the Haven 1, this is a smaller version of their space station, just a single module, and they're planning to launch it in 2025. So that's just a year away. And over the next couple of years, they're hoping to have 4 missions visited. Like probably it'll be a Crew Dragon with space tourists or maybe other astronauts visiting the station over the next couple of years. And last week at the International Astronautical Congress, they announced the plans for Haven 2. This will be a much larger module. It'll be 5 meters across and it'll have to launch on a Falcon Heavy. And this entire module will have twice the volume of the original Haven 1. But then they're planning on launching multiple Haven 2s and docking them together into this sort of long string. And then assuming all of that goes well, they're planning on launching a central core, and then they'll reorganize the rest of the Haven 2 modules around that. And so eventually you'll get this central core with 4 spokes coming out of the center, each of which has 2 of these Haven 2 modules on it. And then at that point, we will have a pretty large private space station. The central core is going to be 7 meters across, and that's too big to fit in a Falcon Heavy fairing. And so that's going to be required to launch in a Starship fairing. So now you can see another use for Starship, not just launching Starlinks. But they are planning on doing this in partnership with NASA. So NASA is going to be an anchor customer for the Haven 2 space station. But then, of course, they're going to bring on space tourists who will be coming and going from the station as well. I like this idea of a fairly modular version of a space station that they could launch. I mean, the small version seems entirely doable with the kind of technology that we have today. The larger version seems like a beefed up version. It doesn't have all of these complicated different kinds of modules. Each one is a very self-contained module with solar wings and docking ports. And so you can imagine in this way, you're just launching them one at a time, connecting them together, and just building as big of a station as you like. And so it seems like a pretty feasible approach to build a replacement station. Hopefully, by the time we're ready to deorbit the International Space Station, there will be this other fully built Haven 2 space station that's operating with people visiting and coming and going, and you'll hardly even notice as the space station plummets through the atmosphere, leaving this fiery trail of debris as it falls into the most remote part of the Pacific Ocean. The first results from Euclid. ESA's Euclid mission launched last year to the L2 Lagrange point, joining Gaia and James Webb, and we've been waiting patiently to find out what's happening with the mission. Now, the goal of Euclid is to build this 3-dimensional map of the universe. Over the course of the next 6 years, it's going to be mapping out about 1/3 of the sky. It's got 2 instruments on board. It's got an infrared detector that's going to allow it to measure the chemical composition of various galaxies and stars that it sees in this 3-dimensional slice of the universe. And then it's got a visible wavelength telescope that's going to allow it to measure the shape of these galaxies and detect the amount of gravitational lensing that's happening from concentrations of dark matter. And so by mapping back into the history of the cosmos, seeing the shapes of all these galaxies and galaxy clusters, it will really try to nail down the location, the amount, the quantity, the density of dark matter, as well as the influence of dark energy that's happening on the cosmos over time. Last week, we got a sample data release from Euclid. Now, this is just 1% of the sky. And this is just a representative sample of what will eventually come with its first data release in 2025. But even with this 1% slice of the sky, it contains 100 million stars and galaxies and other objects. And this blue cloud that you're seeing, this is the interstellar medium, which is clouds of hydrogen gas that surround the sun and really make up the structure of the Milky Way. And it's going to look really cool as they get more and more of this together, and we can see the map of the interstellar medium around us. And what this does is this provides astronomers with real legitimate data that they can then use to, develop their software, to analyze it, to search through it. And so when the full data release comes out in March 2025, they'll be ready to be able to start asking some questions and finding some answers with the Euclid data. Lasers, lasers, lasers. All right, let's talk about lasers. Now, first up, I want to talk about NASA's Deep Space Optical Communications Experiment. And we've talked about this a few times. This is this new communication system prototype that they installed on board the Psyche mission. And this is a spacecraft called Psyche going to an asteroid called Psyche. Onboard Psyche is a transceiver that is tuned to infrared light. And this allows it to send and receive infrared signals from base stations back on Earth in California. And they've been doing a series of tests. And during sort of the first version of their test, as the spacecraft was approaching the distance of Mars, they were able to maintain communications bandwidth with the spacecraft at 267 megabits per second. Now, this is broadband bandwidth speed. Not like maybe if you have fiber, it's better, but still, often spacecraft communication speeds are measured in kilobits. And so the fact that they're receiving megabits per second is really impressive. And then they continued to perform a bunch of tests until the spacecraft was out to 390 million kilometers away. And they were still getting speeds of about 6.25 megabits per second. And that is still, that's plenty. And they did a bunch of ridiculous transfers, sending high definition cat videos and other stuff to and from the spacecraft. They're going to be starting up a phase 2 test in November where they try to just run this system continuously over the course of a year. And once these tests are complete, I think this is a paradigm changer. I mentioned this when we first started to talk about the story, that I think this is one of the most important stories of the year, because there are a lot of spacecraft out in the solar system. The Deep Space Network, which is the way that NASA communicates with all of these spacecraft, is overloaded. And the bandwidth that these spacecraft have to use to be able to send their data back home to Earth is really limited. And so if you can equip every spacecraft with one of these infrared laser communication systems, if you can update the Deep Space Network to be able to handle these kinds of communications, it will revolutionize the way we communicate with probes across the solar system, especially the ones that are really far away. I mean, New Horizons was communicating at just bits per second. And just imagine if we could get more images, more data of places that we've just never seen before. With New Horizons, they had to wait 18 months to get the data back from a flyby that took a day. So this will improve things. And speaking of lasers, now we've talked about the European Space Agency's LISA mission. This is the Laser Interferometer Space Antenna. And this is a mission that will consist of 3 spacecraft flying in a triangle where each spacecraft is about 2.5 million kilometers away from one another. And the spacecraft will have lasers that they are firing at each other. And then they're going to be bouncing those lasers back, and they're going to be able to measure with incredible accuracy the distance between the spacecraft. And so as a gravitational wave sweeps past the spacecraft, it's going to change the length of the legs of this triangle that the 3 spacecraft make up. And NASA is building the telescopes and cameras that will receive these infrared lasers. And they showcased a prototype this week. It's this gold telescope mirror that is designed to reflect infrared light coming from the laser. Each of the spacecraft will be equipped with 2 of these mirrors directed towards the other 2 partners in the triangle. And so with this prototype completed, NASA is now going to work on building the actual 6 versions for the spacecraft. And so, we're still waiting until the mid-2030s that this mission is actually going to launch, but we are seeing progress. There could be hope for red dwarf planets. Now, we've talked quite a bit about the potential fate of planets that are orbiting around red dwarf stars. The problem is that when they're young, red dwarf stars are really tempestuous. They fire off really big flares for their size. And if you want to have planets that are within the habitable zone around these stars, because the stars aren't putting out a lot of light, the planets are going to have to be huddled up very close. And then you get these really powerful flares hitting planets that are too close. And the consequences have been thought that it would just strip away the atmospheres off these planets, that they would be uninhabitable. We're still waiting for the detection or non-detection of atmospheres at some of the TRAPPIST-1 planets, but researchers have come out with a study that says that there could be hope. And this comes down to the fact that as planets are newly forming, you've got them cooling down, and there's a lot of volcanic outgassing that continues on early on into the history of a planet. These volcanic gases escape from the planet, they mix with other chemicals on the surface of the planet, and they turn into an atmosphere. And the study says that if the planet is far enough away, still within the habitable zone, then it can constantly replenish its atmosphere, even as the star is continuing to batter it away. And eventually, when the star settles down, then you're going to continue to have this replenishing, and it will have an atmosphere over time. So there could be hope for these planets after all. And if you're interested in this story, I'm going to be interviewing one of the researchers behind it. So you should subscribe to the channel, and then you'll get a notification of when that interview goes live. The first triple star system with a black hole. Many stars are in triple star systems. In fact, for the most massive stars, they're more likely to show up in multiple star systems. And so if you've got these massive stars, it's not surprising that some of them are going to detonate as supernova and then become black holes. But astronomers have never found one of these triple star systems before, but now they have. You're not going to be shocked to find out what made the discovery. It was ESA's Gaia mission that was able to detect the movement of the 3 stars in a system. So the system is called V404 Cygni. It's located about 8,000 light years away from us. And at the very center, you've got a star orbiting around a black hole in this really tight orbit. And then there's a third star that is orbiting this pair and takes about 70,000 years to orbit around. Astronomers were familiar with the central star and realized that there was a black hole there. They were also familiar with that third star, but they didn't think that they were connected together because this third star is so far apart. But thanks to Gaia, they were able to tell that yes, indeed, it is actually orbiting that binary pair at the center. So now we're just waiting for various combinations of black holes in double and triple collections. And one of the big surprises about this story is how you could even have that third star that's orbiting the 2. Because when that massive star went supernova, it should have provided a kick to any loosely gravitationally bound objects to the system. And that includes that third star. And so this is now the big mystery, is how did the supernova go off and that star still remained in orbit around them? Every week, we do a vote on our channel where you tell us what you thought was the best story of the week. And this week, we did something very different. And that's because we knew that you were all just going to vote that the first test of Starship and Super Heavy was the top story of the week. And so we wanted to give the other stories a chance to compete. And so we first had a poll that didn't include the Super Heavy and Starship launch, and you all thought that the launch of the Europa Clipper was the most important story of the week, and I 100% agree. What an amazing launch. I can't wait to find out what happens with Europa Clipper. And then we asked you to tell us what you thought was the best part of the Starship Super Heavy test. And not surprising to me, you all liked the catch of the Super Heavy booster. So thank you everybody who voted for one or both of the votes that we posted on the channel. Now we'll post this week's poll into the community tab on our channel, but if you're just scrolling on YouTube and you've watched a lot of our videos and you've already interacted with our stuff in the past, you should see the poll come up. Take a second, give us a vote. Now, the best chance to see it is subscribe to the channel, click on the notifications bell, watch a bunch of our videos, interact, then you should see it. A natural particle accelerator at the center of the Milky Way. So on a mountain in Mexico called Cerro La Negra, there is an observatory called the High Altitude Water Cherenkov Observatory, or HAWK, which is such a cool acronym. I like it. And this is a Cherenkov observatory. And the way these work is that there are gamma rays that are hitting the Earth. Now, the problem is that the Earth's atmosphere blocks gamma radiation. And this is why if you want to have a gamma ray observatory, you have to go to space. All of the gamma ray observatories are in space. But there's a hack, there's a trick, which is that when gamma radiation strikes the Earth's atmosphere, it produces a shower of particles. And you can have detectors on the ground that detect the shower of particles, which you could then trace back and know how much energy the photon that struck the atmosphere had with it. So over the last 7 years, the Hawk Observatory has detected 100 separate events of 100 tera electron volt gamma radiation striking the Earth's atmosphere. And a lot of them are seeming to come from the center of the Milky Way. Now, this is not a surprise. There is a supermassive black hole at the heart of the Milky Way. But here's the crazy part, is that to get a gamma ray that hits the Earth's atmosphere at 100 tera electron volts, then you need to have gamma radiation that is coming off of the black hole in the petavolt range. You need radiation that is 1,000 times more energetic than the ones that are hitting the atmosphere. These peta-electron volts are leaving from the vicinity of the supermassive black hole. They are hitting some interstellar hydrogen, and then that is causing an emission of the secondary radiation that is making its way to the Earth and coming through our atmosphere. And so if we didn't know that there was a supermassive black hole at the heart of the Milky Way, we could detect this radiation and have a sense that something is going on at the core of the Milky Way. But another possibility is that there are other compact objects orbiting around the center of the Milky Way. You could have neutron stars, other black holes. They're interacting, maybe they're producing particles as well. And so using this way of measuring radiation coming from the center of the Milky Way, astronomers are better able to understand and map out the environment that is around the central supermassive black hole. Different heat shields for different atmospheres. Atmospheres give spacecraft designers a free lunch because you need all of this energy, all this propellant to get your spacecraft up to orbital velocity. But if you want to come back down and stop, you just have to enter the Earth's atmosphere, be able to withstand thousands of degrees temperature, and use the atmosphere to slow your spacecraft down. And so otherwise, rockets would need much more fuel to be able to do the kinds of missions that we have. And we're very familiar with the way spacecraft perform as they're entering the Earth's atmosphere. And we've got some experience on how they perform as they enter Mars' atmosphere. We've sent spacecraft into Venus's atmosphere and even into Titan's atmosphere. And now there's a whole new set of spacecraft that are to be targeted at these different atmospheres. And so researchers for the Department of Energy have been using this really cool facility. It's called the Sandia National Laboratory. They have 200 giant mirrors set up in the desert, and they're able to focus the light of the sun down onto a single spot and make that spot get 3,500 times more energy than just regular sunlight, and that heats it up. And so engineers have been testing what would happen to various kinds of capsule material as it's being hit by different amounts of energy, and it allows them to simulate what would it be like for a capsule to enter the atmosphere of Venus, the atmosphere of Titan versus the atmosphere of Mars. Now, keep in mind that the atmosphere of Titan is 4 times denser than the atmosphere of Earth. And this is important because we've got the Mars Sample Return mission that's going to be trying to go and land and retrieve a sample off the surface of Mars. We've got the Titan Dragonfly, which is going to be going to Titan. It's really important to understand if these spacecraft can withstand the entry into the atmosphere to claim that free lunch. Actually, this was a topic that we covered in this month's patron-only question show. And so if you are interested in the answer, definitely go and check that out. This month's episode was almost 4 hours long, but once you subscribe, you get access to the whole back catalog, and each one is 2 to 3 hours long, plus all the additional audio from all of the question show. So go to patreon.com/universe today. While you're watching this week's episode of Space Bites, I am writing my weekly email newsletter called The Guide to Space. This week, you might see such stories as life can maintain a habitable environment in hostile conditions. Webb discovers a rich population of brown dwarfs outside the Milky Way, and dark matter has a firm grip on these galaxies. So if this sounds interesting to you, you want a lot of space news showing up to your email inbox every week. I write every word. There's no ads. It's completely free. Go to universetoday.com/newsletter to sign up. Now I'm going to talk about the return of the virtual star party, but first, I'd like to thank our patrons. Thanks to Abe Kingston, Adam Schaefer, Barry Lake Roofing, David Gilton, and David Matz, Dennis Alberti, Dustin Cable, Jeremy Mattern, Jim Burke, Jordan Young, Josh Schultz, Paul Rohrbach, ScienceWorldRecord.org, SpiderSwap.io, Stephen Krasaki, Stephen Fowler Munley, and Vlad Shiplin, who support us at the Master of the Universe level, and all of our other supporters on Patreon. So one of the most requested things that we've had here on the channel is for us to bring back the virtual star party. And for those of you who are new and you don't remember the good old days, this was when we would gather together a bunch of astronomers with telescopes every week, and we would just look at different objects in the night sky, depending on what was up and what people had. And it's a really fun experience. We chat about what it takes to be an astronomer, what kind of gear to use, but as well as like, what are we looking at and the science. We had a great time. And we've had to shut it down multiple times because it's just so complicated to maintain it. But we've had an incredible offer, which is a company called Starfront does telescope co-location, and they're supplying us with a telescope in pristine dark skies that we can use to bring back the star parties. Now, we're still in the process of setting up and figuring out what we're able to do, but here are a bunch of pictures that I've taken with the telescope of comet, of deep sky objects, and the moon, and so you can get a sense of what's going to be possible. So we should be returning with the virtual star parties within the next couple of weeks. I'm really looking forward to it. I hope you are too. All right, we'll see you next week.